Some of the answers in the back, instead of like 360K, would be 180K.
Sure.
We talked a little bit about it in class, but I'm still kind of confused on how.
Absolutely. Is there one particular problem that has that?
Number
Besides
5.
number 5, you got it, Haley.
Do we do number 29?
29, absolutely. Okay, any others? Going once, going twice. Sold. Okay, let's jam with it here. So tangent usually is the one that gives you that little 180 piece. And it's because the two answers are exactly 180 degrees away from each other, or pi. So it's a half a rotation away. So let's jam with it here. We're looking for, this is the A and the B part, is that right? A says I got to find all of them. B says just from 0 degrees to 360 degrees, not including 360 degrees. And then it says this refrain, do not use a calculator. Okay, fine. There's the law, then there's the execution of the law. That's a little different there.
So you can't read or read both.
All right, this is the easy part, solving. And I got tangent theta is equal to a -1. Okay, with that, then we're looking for, on our unit circle, since that looks like a unit circle, we're looking for the x and y coordinates to be the exactly same number, but then opposite signs. So this one is not going to work because this one is positive root 2, positive root 2 over 2. This guy is going to be, oh, that one works. That's nice. This is what, the negative root 2 over 2, positive root 2 over 2. And then this other one over here is going to work because that's a positive. Okay, are we okay with the unit circle stuff right there? Cool. Okay, so I figured that's the answer, and that's the answer. Are we good? So it is totally okay to write it. Let's go with A, all the answers. I like B first, right? Because B gives us that little angle there is 135. And this little angle here is 315. Cool, according to unit circle, there it is. And for part A, it is A-okay to write it as this right here. And then you have that. K is an integer. And that would be a totally correct answer and should be accepted. We're good? All right. The other way of writing it, because they are exactly 180 units away from each other. So let's go a little bit deeper in here. So if I put in 0's K, right? That gets me the 135 marker. We good? If I put K's 1, that gets me 135 plus 360. And so as I do that, whatever that number is going to be, we good? And so it just kind of swings around the unit circle. Here's my first one. My next one's going to be like this. My third one's going to go even further, right? So you're just rotating each time. And the whole point here is really just to give me all the answers. Can you give me all the answers? Well, since they're exactly 180 units away from each other. In fact, can you guys do this for me real quickly here? Give me, if you guys could add 360 here, what's 135 plus 360? Quick here. Anybody have a calculator that they can do it with? 195? 495, is that right? Okay. Ooh, and one more, another 360 on top of that. You can use a calculator to do this, that's fine. 855 maybe? 855? Okay, so I got those. All right, and then we do the 360, 315, right? If it's 0, I got 315. If it's 1, add that to that. What is that? 6. Is that 675? Okay, and then we can go the opposite direction too, right? We can go the -1, -2, -3, which cycles it back the rotation. Okay, or we could do this. We could say 135 plus 180 degrees K. K is an integer. All right, so let's take a look at this one here. So if K is equal to 0, let's do this little list down here. If k is equal to 0, I have my 135. Agreed? If k is equal to 1, what's 135 plus 180? Hey, 315. Then if k is equal to 2, 2 times 180, isn't that 360? So it's really technically 360 plus 135, which gets me this number right here. And I can keep on going. If I put in a 3 here, it's going to be 1 full rotation and half a rotation, right? So that gets me this one. Grant, are we okay? You just like throwing away pencils, or it didn't work? It broke. Okay.
It was a bad.
Bad pencil. Okay. All right, guys, does this make sense? Right? So.
Yeah, you would just put 135 plus 180K. Correct.
Yeah, it usually works for tangent because tangent is always going to be, or cotangent, they're always going to be 180 degrees away from each other. Sometimes when you're dealing with the sine and cosine, sometimes they'll just work out that way. Oh, that's cool. I can write it as a more simplified version. Yeah. Okay, does that make sense?
Yeah.
A little better. Cool. Okay, 29. 29. For each of the following, again, all degrees. And then 0 to 60, do not use a calculator. Everybody okay with the chicken scratch there? Cool. This one a little more complicated, not by much. The question is, how do we solve this? First of all, there's 2 trig functions here. Anybody with an idea?
Did you change it to sine and cosine?
Oh, good. When we were simplifying, remember we were proving that one side is equal to another side. Remember how we changed everything to sines and cosines, and we try to simplify it as much as we can. Go for it. On this one, we don't want to do that unless we have to. But we have ourselves any algebra rules. If we can add the same number to both sides, we can multiply the same number to both sides, we can factor, and we have quadratic formula in our hands. There's our little rules from algebra.
Can you factor tangent?
I think they're probably the same way. Notice there's a tangent here, and then there's a tangent right there. So that at least will separate them out, especially since it's equal to 0. That kind of helps out. So how about this? Tangent theta, oops, sorry. Tangent theta gets factored out of here. And I'm left with square root of 3 minus 2 sine theta. Perfect. So if you have 2 different functions, if you can factor it out, please do so. I got 2 things that are multiplying to give you 0. Therefore, now I can separate them out. So tangent is equal to 0, or boom. All right, unit circle. Tell me when tangent is equal to 0. That's 0 and 180. 0 degrees, 180 degrees. Notice we should mention this up here. A is all solutions. B is just from 0 degrees, and it does not go up to 360. So don't do that one. It's only up to 359.99999. This one needs a little bit of work. How about subtract square root of 3 to both sides? Divide by -2. Boom, and I'm looking on the unit circle when sine is √3/2.
So it's 60 and 120.
60 degrees, 120 degrees. I agree with that one. All right, now I'm ready. So part B goes first. 0 degrees, 180 degrees, 60 degrees, and 120 in any order whatsoever. It doesn't matter if your order doesn't match the back of the book. And let the fun begin. I got, let me do it in order here. So 0 degrees, 180. fun little piece right here. Notice it's a half a rotation all the time, right? So it's gonna be 0 degrees plus 180 degrees K. That takes care of the 0 and the 180 at the same time. Perfect. Then I have 60 degrees plus 360 degrees K. 120 degrees plus 360 degrees K. And how about this? Where K is an integer. Awesome.
In
Cool.
the back of the book, they don't write that every time.
Oh, they just leave the K
Yeah.
as assumed.
Yeah. So,
True.
because I wrote it for the first 4 and then I was like,
That's fine, yeah, as long as we know what we're talking about. Yeah, if we had different Ks, then it'd be a problem. Okay, we're good. And 69. Find the angle of elevation of a rifle barrel. If a bullet, can't draw a gun. What's up with that? I'll go like this. Fired at 150 feet per second. Takes 2 seconds to reach a height of 750 feet. To the 10th of a degree. All right, so it's not faced sideways, it's faced up like this. And okay, what should we do? Takes 2 seconds to reach 150 degrees. I guess we've got equations on our hands, right? There's an angle right over here. And if we make this into a triangle like this, will that help a little bit? And if I'm thinking about height, there's 750 right here. Oh, that's that would be height. That's what I want to see. Cool. And let me check one thing real quickly here. Let's see if they did a, oh, of course. If you go back to figure 9, which is one back page, you have this little equation here, which I should have mentioned in class. There's your height equation. It says a projectile, such as a bullet fired into the air, initial velocity is v. That's velocity. Angle of elevation is theta, obviously. Then the height of the projectile given time t would give us this equation right there. So let's jam, let's put stuff in here. So find the angle of elevation. So we need to find this guy. That's the one that we don't know, but I know 750 is here. Negative 16 takes 2 seconds to get there. Initial velocity was 1,500 feet per second. 2 seconds, and then we have ourselves sine theta, and we actually got to get to sine theta. Okay, talk about working backwards here. Let's see. 2 times 4, 16 times 4. 64, is that right? So negative 64 there. This would be 3,000 at that point. And how about if we add 64 to both sides? And you guys watch me make sure I do the work here correctly here. I got 814, is that right? Divided by 3,000. So now I'm here. And that could be reduced, that's no problem. What I want to do is just do this here. So in order to get rid of sine theta, I have to take the inverse sine theta. 814 over 3,000. And anybody have a calculator? I can punch that in. Let's see, make sure you are in degrees first. And we're going to go to the nearest tenth of a degree. And we're looking at sine theta of 814 over 3,000.
About 15.7.
Okay, anybody got the same? All right, and did Bob get the same thing? Who's Bob? Say again with that? Bob, no, I don't have it on paper. Back of book. Bob. Come on, we all know Bob.
Remember the Bob, remember we called our binders Bob? Yeah.
Big of binders or Bob?
Oh,
We
yeah.
had the original Bobs,
Yeah.
and the ones before us called them like bolts and stuff like that. And then everybody wanted to call them Bobs because obviously we were just like so cool and such trendsetters. Yeah.
It's true, we were.
All of us in third grade.
Yeah, as third graders, absolutely.
That's so funny. 15.7, that's what I got here, so we're good.
No, you.
Bob agrees with us. Bob is a good friend. You know, he may be a binder or the back of the book. Okay, are we good? Let's jam. Let's keep on going here.
So are
So,
you just gonna put a thing on the Google Classroom like tonight?
yeah, do tomorrow. Yep. Okay. Boom. Hi. That's strangest thing. Okay. All right, let's see how much we get through. 6.2, but let's go with it.
That's probably one
Let's see, I get to bug people. This is fun. 6.2, just an outline of what we're going to do. And if you kind of think through chapter 6, our equations are just getting more and more complicated. That's all. So 6.1 had a little bit of identities, not much. So now we go on to 4 more. So now let's go in with some more identities. And actually, if you want to do this here, you can plug in. So the first 2 examples are going to be this one. I figure I'll do one and then I'll let you guys practice on one. Clearing denominators. So now we have fractions on our hands. That's cool. Solving trigonometric equations by squaring both sides. That's cool too. And then this one's just gonna be 1. So graphing it by a calculator approximating solutions. Let's jam. Example 1. Da, 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 da. And if you know it, go for it. Let's see. And then I always want to, which side of this do I want to start bugging people on? Corinna, good morning to you. So I figure, ask you what you think we should do, and then from there on out. Also notice there's no A and B parts anymore. What happens here is we're trying to get into sort of real life circumstances. So we're just going to look at one rotation. Sometimes it's in degrees, sometimes in radians. Because in real life, you would just do one rotation anyways and be done.
For real reference, you don't have to calculate literally every single
Forever.
Because
Forever.
things go into infinity in real life.
All the time.
Yeah.
I don't understand that.
Calculate it to infinity.
Corinna, all yours here.
You're right, I won't.
What should we do? What identity can we use?
Good job, buddy.
Wait, identities are like, would you change the sine to theta to sine?
Oh, gotcha. So yeah, I see this one. This one's nice plain trig function, right? This one's not so much of 9 place because that little 2. So to think back in your mind, like, hey, is there any, because that's the problem. That problem is that little 2 theta inside there, right? Is there an identity that gets me out of that 2 theta? I think so, right? It's, there you go.
Yeah. Wait, did I say that?
I think you did, yeah. Just want to make sure the rest of the class heard it here. So off to the side here. So sine, it's the double angle formula for sine, I believe, right? So not I believe, I better know it, or else I should not be teaching this class. Sine 2 theta is 2 sine theta cosine theta. Perfect, let's put it in. So 2 sine theta plus now this little okay. So what you probably should do as you guys are doing these problems is have the front cover these little identities right in front of you. Just sitting, photocopy, whatever you want to do, just so you sort of see it. You should be able to do it a lot easier than just trying to recall it from your mind. Hayden, all yours here. What should we do next? I see a sign in one term, I see a sign in the other.
Take out 2 signs.
Oh, perfect. Yeah, I didn't even think of that. I was thinking of taking sine, but 2 sine works as well. 2 sine theta is added here because we have 2 terms that are adding or subtracting each other to give you a 0. Therefore, we can factor stuff out. I'm going to go with 1 plus cosine theta. Sweet. Haley, all yours. Say again.
Divide by the 1 plus cosine?
Can't do it because we have a variable called cosine theta inside there, so can't do that. But I have 2 things that are multiplying each other to give me 0. So yeah, it's the factoring rule. So 2 sine theta is equal to 0, or 1 plus cosine theta is equal to 0. Sweet, and then we'll get to solve each of them here. Rylan, all yours. What should we do right there? Sweet, Let's do 0, and then I have, one of these guys again here. So let's see. I'm guessing it's going to happen at 0, is that right? And it also happens at 180. Okay, keep that in mind. Go to the other side here. All yours, Georgia. Finish up the other side. And when does cosine theta equal -1? Gotcha. I think it's 180, right? It's when the x coordinate is -1. And you know, if it's a -1 or 0, it has to happen on somewhere on the axes, right? For sine and cosine. Boom. Oh, repeated answer. I like repeated answers here. So 180, 0 and 180. So therefore, just 2 of them. There they are. We'll get into some applications later here. We're just learning how to solve equations. Okay, are we good with example number 1, guys? Very similar. All right, a little thought question here. Cosine 2 theta, since we did sine 2 theta earlier, now it's cosine 2 theta, and I have an x in there now instead of theta. Well, one little itsy bitsy small problem is that, remember cosine 2x? How many different equations do we have for that? 3. Yeah, we have 3 different ones. Oh boy. So we're going to choose the first form, second form, or third form. So Nicholas, you get to be our chooser for us. Choose wisely. Which one do you think we should use and why? Ooh, there he is. How about that? Which one to use and why?
I think the second one.
How come is?
I don't know, I just have a
I
feeling.
have a feeling.
Because it has cosine in it.
Oh, that's right, look.
Equals-
Yes, because that guy, we have a cosine in the other term, right? So if we want to have all in terms of cosine, we better use that one. At least help us out here. Because then we have sine and cosine inside it, and it contemplates. Oh. So that piece right there. And if you want to put parentheses around it, I like to, because then it tells me exactly what I substituted. And Grant says we have ourselves quadratic equation. Yes, yes, yes. So let's do this here. So 2, let's put it into trinomial form. That guy goes first. Then this guy goes next. And then the one without the cosine at all goes over here. That's cool. And we're gonna bother Grant today. Grant, what do we do? What do we do?
You can try to factor it.
True, true. Before we factor, what do we have to set it equal to?
0.
Uh-huh. So let's do that. So subtract that from both sides gets us boom. Okay. If you're having difficulty here, then what you do, you just kind of go back to algebra just for a second here. And you just replace the cosine x's with just regular x's from algebra. And the question is, does this factor? Since you guys are experts in algebra.
Who made us experts in algebra?
You
Yeah,
passed.
who told you that?
I assume you passed the course. How about that? Let's see, Grant or Matthias, how about that?
I think Grant.
2x squared minus x minus 3.
I just kind of, it doesn't look.
Doesn't look good, huh? Let's see. Only thing is, because you have a 2x squared right over here, that's easily to put down. The only way you get a 2x squared is 2x times x. That's it. There's no other way to do that.
Isn't it 2x minus 3? And then x plus 1?
Let's go with it here. Yeah, we sort of play with the numbers here. So 3 and 1. And so we go with, let me do it this way here. 3 here, 1 there. So I'm going to multiply this guy here and this guy. Looks like a little baby.
Looks like a baby. Let's go. Let's go.
No?
What?
Wait, what?
I So this is, never mind.
We're all
Let's see, I guess I need the minus here. Is that right? I need the plus there. Are we good now? Without the baby? Have to go into it here just for a second here. Does that look like there's the baby's head
Oh.
and there's the baby's like mouth and stuff, and then you can, whoa, that's sharp teeth.
This is a big fire baby.
Now it looks like SpongeBob.
Yeah.
So my trick teacher used to say we check the baby's head right here, and we check the baby's mouth, and I have no clue why that stuck. But adding those together gets you a negative x. Is that true?
Yeah.
That works in algebra. It has to work in trig as well, except that x is now cosine x. That's 2 cosine x minus 3, and then it is a cosine x plus 1. That will work. Cool. Okay, let's solve each one of these guys here now. Separate them out. I need extra room here, so I'll let you guys write. So 2x, 2 cosine x. Let me rewrite this over here. 2 cosine x. Oh, actually, no, I'm going to set equal to 0 here. That equals 0, and x plus 1 is equal to 0. Matthias,
Yes.
what should we do next? So Grant staring at you, does that add extra pressure?
No, I think.
Have an Adrian staring at you at the same time?
Finding the like thoughts in my head.
Okay.
I think that's the biggest problem.
I'm not going to tell you to add 3, but go ahead. What would you do?
Would it have something to do with the unit circle?
Eventually in a circle, yeah.
Also,
Yeah, we're just simplifying the equation right now, right?
Yeah, Adding 3 maybe?
maybe.
Yeah. I'd go with that. Adding 3 to both sides, because we're just trying to get cosine x by itself.
Add 3 to the right.
So we're going to do that.
3 to the right side.
And Matthias, go for it. You got to get at least one correct. Thing.
Add 1.
Add 1 to the other thing.
Add 1.
What?
Grant may be telling you the wrong thing to do.
Yeah.
You want to divide it.
But-
No, he said add 1 before I said. I'm asking him if he really wants
Wait,
to.
but if we're trying to get the cosines by themselves,
It's already-
would you not?
It's already addition.
Wait.
You said add 1.
Wait,
Try to divide it. It's the other one.
So divide it.
I'm so sorry.
Subtract or logarithm, you know?
Yes, it's a logarithm, absolutely. So let's go
I'll
with.
get there eventually.
You might want to try to sum the product.
I'm going to divide by 2.
Yes.
And then this one, he actually did say subtract 1 technically.
I knew it was logarithm.
That's cool. Adrian, all yours for this one here. A unit circle, where does cosine give you 3 halves?
Oh, that's a good
Two.
question. Wait, where does it do that?
Yeah, where did it do that? I know square root of 3 over 2.
Yeah, you're not gonna find it in the book. Because it's 1 and 1/2, which is more than cosine. Oh,
Absolutely, yep.
formula thing.
Cosine is, or has to be between -1 and +1. There's never a time it's otherwise. Therefore, this guy has
The chunk is 0.
0 with the equal line through it.
The chunk is 0.
On the other side, cosine x equals -1. Zechariah, all yours?
I'll say that half.
180, yep. I'll go with that right over here. That's when it says -1, 0. Perfect final answer.
Unit square. Unit square. The art's now good.
Is such thing as a unit square.
Unit isosceles. Yeah, scaling triangle. Unit impossible triangle.
Okay, good. Are we good there? Good
Triangle
that.
whose angles add up to 190 degrees.
Zechariah, good job with that one. Give me that.
The unit icosecant.
Wait, is this
You have
one
to
a
use
denominator
3D
one?
space.
This is a what do I want?
Because you said on the
Dimensional unit.
Huh?
slide thing. that
Clearing, yeah.
Example 3 and 4 are gonna be denominator.
Clearing denominators,
They are.
And the unit circle does come up later.
Just because now you have, it's not so much as that you have fractions, is that you have your variables inside the fraction, or it's at the bottom of the fraction here. So let's go with it here. So solving cosecant theta equal to 2. I guess we could do it one of 2 ways. I guess, yeah, we could do one of 2 ways. Yeah. So first things first, normally what we do is we want to change it back into sine and cosine. So cosecant theta. Going back, should we go the other way? We should go the other way. Grant, cosecant theta is 1 over what?
Wait, didn't you just say we shouldn't do that?
Yeah, we should now, though.
For what?
Like,
Yeah, sure.
Haley suggested it earlier and you were just like, no, that's not how we do it. That's not how we're doing it
But
right
that
now.
was for tangent.
Okay.
Cosecant is special.
Oh, sure,
Cosecant is special.
sure. Let's go back. That was on the homework, right? Or no?
Was it? Yeah, well,
Was it on the homework or here?
if I looked there, I might find it.
Is it on the homework, Ken?
If I did the homework.
So changing tangent and sine and cosine complicates it because now you're going from one trig function now into two different trig functions here. You good? As opposed to here, you are just replacing one to something you already know, something you can calculate with your calculator, all that stuff there. So that's why.
So it is because cosine is special.
It's either sine or cosine.
Good job. Yep, that is true.
Just pretend like cosecant isn't there, replace it with a sine or a cosine.
Second replace.
Yeah, I think that makes sense.
Yeah.
Change the problem.
How is
Something else.
It's a totally different thing.
Are we good there? Now we've got sine theta. Think back to algebra days here. Oh, hold on. So we have a fraction in our hands, right? We're going to try to clear out the fractions here. So I'm going to multiply both sides by sine theta over here and sine theta over there. Think back to your algebra days. I know it's been a long time. What's the only number that you can't multiply both sides by?
Infinity.
Okay, never mind. What two numbers? You
Infinity and negative infinity.
What three numbers you can?
Five.
Hold on, I'll go back. Hold on. Infinity is not a number technically. It's a notation. So yes, what number can you not multiply both sides by? I think it's 0. Is that right? Okay, so off to the side, what you're gonna have to do is you have to write this here. So sine theta cannot be equal to 0. Once you do that, infinitesimal still works, yes, but not 0. So if we're gonna get something down here, which is sine theta is equal to 0, we won't be able to use that as an answer. We're good. I think we did those before when you guys were doing in algebra class. Oh, do you guys remember these problems like this? Or like
Did it have
2x.
something to do with making circles and the ovals
Oh, those are conic sections. No,
Oh,
not those.
and
These guys are called rational equations here. So you have variables on the bottom, and then you had to determine, like, you know what, x can't be equal to negative 5/3 because it's going to give you a 0 on the bottom. So you can't use those answers. You guys remember that? Did you remember that?
I remember seeing that.
Say
I
all
don't
of
remember
what
what
you
to
just
do
said
with.
Okay, gotcha. All right. So never mind on that.
Wait, question.
Yes.
Does a number over 0 count as a number?
0 counts
Isn't it
as a
a
number.
No, but if you're dividing something by 0, like as a fraction, is that a number? You probably can't multiply both sides by that either.
Yeah, no, can't divide by 0.
Aha. 1 over 0 also doesn't work.
Yeah, 1 over 0 does not work.
You don't have to write that down though.
Yeah, it was crucial to establish that.
In fact, yeah, there's some fun stuff about 1 over 0. It's the same reason why it's actually the proof why we can't divide by 0, because it's a non-number at that point. Yeah. Anyways, how do we clear zeros? We go like this, because if that's 1, those 2 will disappear on us. And we're left with this. And who am I bugging now? Oh, Adrian. What should we do next to solve for sine theta at least?
Whether to divide or to multiply.
I go with divide.
Why would you?
Well, I mean, you could just square both of them. I'm not sure where that would get you. So
We'll get there, just not
probably
yet.
divide by 2.
Divide by 2, all right. So I got square root of 2 over 2 is equal to sine theta. That's cool. Let's go back in our, oh, Zechariah, all yours. Unit circle, talk to me. When do we have sine theta is equal to root 2 over 2? I should pick up people that don't have their textbook. That'd be fun. Like, oh, shucks.
So it
That'd
could
be
be
so
like,
mean.
I don't
That
know,
was fun for
like,
me.
what?
It's 45. and I don't know. the other one.
45 and? So looking for the y value, right? The y value root 2 over 2. Say again, Skin?
135.
135, yep, perfect. Right over here, and I'm done. There it is, so 45 degrees and 135 degrees would be my two answers. We never had this situation come up, so that's cool. Okay, let's see. Okay, we're good. You know, let's, we're halfway there. No, this one will be a little bit longer here. So let's stop here for today. We're good? We'll do 4, 5, 6, and 7 on Friday.
Oh, Lord.